Hi guys, we already talked a little bit about inverse operations. And so what we're trying to do is undo the operations in order to basically unwrap our gift of, well, the variable, the unknown. Usually we call it x, but it could be any variable actually. And remember that idea of balancing. That's the big idea. When we have this equation sign here, for example, we could argue, we all know that 4 is equal to 2 plus 2, right? So when we say balance, we're talking about whatever operation I perform to one side, I do to the other. So if I'm going to multiply by, say, 2, let's say by 3. If I multiply this side by 3, that's going to be 12, right? I also have to multiply all the parts of this side by 3. I have to erase that. This video, I can't just press the reboot. It doesn't work. I did that last time and it restarted the whole thing. So times by 3, and also this part we have to times by 3. And so that would be 6 plus 6. We know those are equal, right? Anytime I do something to one side, I do the other, okay? Always keep that in mind. If I add to one side of the equation, so if I'm going to add, let's pick another color now. Red, we'll say. If I add to both sides, now I'm going to have 14 is equal to 6 plus 6 plus 6. 6 plus 6 plus 2 is, 14. Okay, so that will work for all cases there. And so what we have equations here, and what we're going to do is perform inverse operations. We're going to unwrap our gift here, but always keeping in mind that whatever operation I do, to undo the operations that are around x, I have to do to the other side as well, so that I'm balancing the equation. Okay. Let's start with the first one. I'll change colors again. Now I want to isolate x. So first, I think if I isolate 2x, that's going to help me a lot. Now, if we look at addition and subtraction, they're kind of like the same thing. Adding and subtracting, they're inverses of each other. And then multiplication and division, so let's put that, add and subtract, and then we'll go multiply and divide. Those kind of pair together. So when we do order of operations, we always do the addition and subtraction very last. We do what's inside the brackets first, and multiplication and division. And we always do the addition and subtraction last. It's just the opposite when we're solving. So what we want to do is we want to undo this subtraction first. So how am I going to do that? Well, what's the inverse of subtracting 3? I'm going to add 3. And why would I do that? Well, I am undoing the subtracting 3, and I end up with 0 here. So now we've got 2x equals, and then since I added 3 to this side, this becomes 8. Okay. All right, so did we do the right thing? Can we add 3 to both sides? Will that make both sides balanced? Yeah. I mean, if these are equal and we add 3 to both sides, they're still equal. Okay, so now I want to undo, this is multiplication, right? So 2x means 2 times x. How do I undo multiplication? Multiplication and division undo each other. So we need to divide by 2. I can show that as a fraction. Divide by 2 here. And now we have, if we divide both sides by 2, they're going to be equal. And by the way, if there was another part here, we'd also have to divide that by 2. So we end up with x is equal to 4. And we can go back and check that. 2 times 4, we're going to substitute that for x, right? Minus 3, what is that equal to? 2 minus 4 times 4 is 8, minus 3 is 5. That's our original equation, so it works. Checked it. All right, so now we're going to look at another equation, and we've got some operations around x. We want to isolate this here first, okay? So this is division, right? How would we undo that? We would multiply. And we can actually multiply first. We could multiply everything by 2. That might be helpful because we get rid of the fractions. Or we could go ahead and subtract the 2 here. Okay, this is kind of like adding 2 because it says 2, so it's the same as plus 2. So if I subtract 2 here Then I subtract 2 here, right? Now I'm going to end up with 0 minus x over 2. So this is minus x over 2. Don't need to write the 0. And then when you subtract 2 from this side, which was 11, we get 9. Okay. Now we've got division. How do I undo dividing by 2? Well, division and multiplication undo each other, so we're going to multiply both sides by 2 and do the same here. Okay, we can do that because we're multiplying both sides by 2. They will stay the same if they're still equal, right? When we do that, 2 divided by 2 is 1. Well, or negative 1 in this case. So minus x equals, and 9 times 2 is what? 18, right? Now we have a negative x. We want to find out what x is. So how can I make this become x? How can I do that? Is there something I could multiply it by or divide it by? What if I times it by negative 1? So I times it by negative 1 and do the same here. That just changes the sign, okay, to the opposite. Times this one by negative 1. So x equals negative 18. And we can check that. 2 minus, we have negative 18 over 2 equals 11. All right, so 2, and this is going to be minus, and this was negative 9, equals 11. 2 minus a negative, that's 2 plus 9. Sorry, minus 9 equals 11. So yeah, that's true. It works. Okay. All right, last question. We're looking at equation that is, well, there's x's on both sides of the equation. That kind of makes things tricky. We really want to end up with, x equals something. Well, it doesn't really matter what we decide. I could decide to isolate this first, or I could decide to isolate this first, and I can eliminate everything from the other side. It doesn't really matter. Let me go ahead and erase some stuff here because there's stuff in the way. What you have to do is trust your instincts and go with something, and then go with it, because you'll find that there's always a number of ways to solve. I'm going to isolate this on the left, okay? So I've got to get rid of this operation surrounding what I want to isolate. So that's a positive 7. So if I subtract 7 to both sides, I'll have negative 3x is equal to x. And if I subtract 7 from 13, I'll get 6, so plus 6, right? All right. Well, before I go ahead and divide here, I know that I've got x's on both sides, so how can I fix that? I need to get rid of the x on this side. So if I subtract an x to both sides, would that be equal? Well, if I subtract the same amount that is x from both sides, they're still going to be equal. So when I subtract an x from negative 3x, I'm going to get negative 4x equals, and then here I end up with 0, right? Now I need to undo multiplying by negative 4. So division and multiplication undo each other. So I'm going to divide by negative 4. We did this on purpose because this is going to be just 1x, right? And then divide by negative 4 here. I can simplify that. That's a fraction, right? Common factor that we can look for is 2. So if I divide 6 by 2, I have 3 halves. Or I could say negative 1.5. Both of those are acceptable. Okay, so go ahead and work through the problems. We just want to practice. Always thinking of the big idea of balancing and using the inverse operations to unwrap the variable. Okay.